now that our masking is done, maybe we can focus on another part of our project. And so let's say we don't want this simple 3D sphere in our shot, but maybe a more interesting object with maybe a little bit of animation. And because of the way our project is set up, it's just a matter of rendering out a different thing from our Maya project and just switching out the renders, and everything will update accordingly, so that's great. At school, you have access to a library of Quixel Megascans. So the way to access this library is with the Quixel Bridge program, and you can download it from the internet from this website, quixel.com/bridge. You just download, you don't have to subscribe or sign in or anything, just download the program and then just install it. And when you've installed it, you will get a pop-up to say like where the location of your library is. Now you have to be on the school network for this, but you'll get something like this, and then you have to fill in this address in the local library path. If you have set that local library path, you'll see some numbers appearing next to downloaded, so you can go to the downloaded, which are all the assets that are on that local library. So here you see all the assets that are in there, and it's mostly materials and also some textures, but there are also 3D models there. You can go through them, you can also search through them. For example, if you search for a rock, you'll see that you get all the assets that are kind of rocks, so some materials, but also a lot of scans. And let's say, for example, that we want to use this volcanic rock, then you can just click on this open in folder button, and then you will get an Explorer window where you can see all the files that are associated with this asset. So we get all these model files. The LOD0 is the most detailed one, so always take LOD0 for our purposes. The other ones are when you're working in the game engine, you might want to have the different level of details. Then you also have, of course, the texture files. So we have an albedo, so a diffuse color map, the normal map, and then a roughness map. So if you want to use a model, it's best to copy the things that you're using to your Maya project folder. So in the assets folder of my Maya project, I've just created a volcanic rock folder, and in there I then copied so the LOD0 model file and the 3 texture files. So in our Maya file, let's then import this model. So I just go to import, and then in the assets folder, I'll find my LOD0, import it. So I want this to be at about the same location here as my sphere. So I just select the volcanic rock, the sphere, and I will modify match transformations all. So I now centered the pivot on the model, and then just with the rotate tool in world coordinate space, I just rotated the model until it's kind of in the direction that I want it to be. So I can just rotate it like that. And so once it's in a rotation that I like, I then freeze the transformation so that my rotate values are again zeroed out. So let's then just put a little animation here. So I'll just key the rotate Y and go to the end of my frame range. And so what I'm going to do is, so we have a long animation in our Fusion project. I mean, the sequence is about 700-800 frames long. But what I can do is just make a looping animation of like a turning, floating a rock or whatever. And then we can just loop that animation. And because this is created on that still frame that we track into our original footage, we can just loop the same animation over and over again. So let's put another keyframe on our last frame of our loop. So, and then it will be at 360 degrees. So let's put a key there. And in this case, I will just make sure that my graph is linear. So let's select the keyframes and just put it to linear. And then if we play it, you can see that we have rotating a rock that is floating above the ground. Or you can put animations on different axes of the rotation and then just get a funky result like this. Or just on two axes, and then you get another kind of rotation like that. So let's then create a material for this object. So in the hypershade, so I'll just create a new window here, and then I will get a standard surface shader and get some images. One for the base color, one for the normal, and one for the roughness. Voila. So in here I will get an image, and so in the volcanic rock asset folder we can get our albedo color map and put this in the base color, get the roughness map. And so as you can see, the color map, the color space is set to sRGB, which is fine, but the roughness map doesn't need that. So I'm just going to put this to raw. Now this is a JPEG, so you would say like, okay, but it's in sRGB color space, but it's a utility map. So we're just using the raw values of this map to then influence the material in our renderer. So if we have a 0.5, so middle gray, linear middle gray value in our color map, we just want to keep it that way. So that's why for these kinds of maps like roughness or transmission or things like that, or metalness, we set the color space to raw. So set the color space to raw, and then let's put this into transmission, no, in specular roughness, and we can just use any of these RGB out colors for the specular roughness, like that. And then our third image is a normal map, so let's get the normal map in here. And this one as well, we just want to use it as in a raw color space. And then from here we need actually a normal map node. So AI normal map, and then we just do our color into the inputs and the out value into normal camera. So let's then select our object and get this onto the object. And let's render our scene. And so here we have our volcanic rock. So because we have an animation, we'll have to render a sequence. So we won't be able to just use Arnold render view, but we'll have to render a sequence. So for that, we'll need to set up a few more options. So let's go to the render settings. And so here at the top, you'll see the path where your images will be saved. So it is in your project folder and then images. And you can change that location if you just go to your project window. And here in the project window, you can change that images folder. So if you want to, for example, just set a render folder, because maybe you find that more obvious. And then you can have, for example, the date of today, like 3 November, and then you can select it there and accept it. And so then you see this location, this path has changed to that location. So when rendering out an animation, we're also going to need a frame number. So in the frame animation, we can put the name underscore and then the number of the frame and then the extension, which is set to EXR. Then of course the frame range is going to be frame 0 to 100, and by every frame we're going to render every frame. And the renderable camera is camera 1, of course. And the image size is 4096 by 2160, so we're going to render out in full resolution this time. So let's also set up some AOVs. So AOVs are like render passes where you can store different information from your render. So let's say that we want to have a crypto mat, so a crypto material, crypto objects, you can add those. It's only gonna be very useful if there are multiple objects in your scene, but I can just show you already how it works. Then we have the 3 shadow matte render passes. And then we of course also want to have a Z pass, and I'm also going to take a motion vector pass. So these are, so the crypto passes are mostly for selecting different objects. So it's actually a matte generator where you can just select an object from your renderer and then apply color correction on it or do other operations on it. The shadow matte passes are only, of course, useful when you're using a shadow matte. But also, I'm not sure if we're going to use this, but in general, I'm in favor of having too much AOV passes than too little. So that's why if I have a shadow matte pass or a shadow matte object, I will just render out all the shadow matte passes. Then the Z pass is if we want to add a depth of field in our composite. And the motion vector pass is for if we want to add a motion blur in our composite. So if you're rendering out 3D objects and you need to combine them with real life footage, you really have to think about these extra things in order to really integrate your rendered objects into that scene. Now for the motion vector pass, the filter also needs to be set to closest. The Z pass is also set to closest. The motion vector is by default set to Gaussian, but it needs to be closest. Then also to activate motion vector data in our render, we need to go to the motion blur tab in Arnold Renderer tab and enable it, and then set just the instantaneous shutter, also enable this. So let's now render this in the render view, so just one frame. And so as you can see, we now have our full resolution, 4K resolution here. So the render will take, of course, a longer time. Also with adding AOV passes, the render will also take longer. So it's always a little bit of a balance that you need to find, of course. Then in this drop-down menu, we can actually see the different passes, the different AOV passes that we've created in the AOV tab. And so if we go, for example, to the motion vector, so here you can see the data, the motion blur data that we'll need to introduce motion blur into our composite. So I now have one frame rendered, and I didn't let it render out completely, but we have all the information that we need in here to test our comp. Because when you're rendering animation, you don't want to just start rendering 100 or 1000 or multiple thousands of frames just like that. You really need to get just a few frames and just test it out in your comp if everything's working. Also just render out a few frames to see if you have a noise problem somewhere. So if you have to increase your render settings or not, or decrease it. So with this frame now rendered, we can just already save this, and I'm going to save this because we have different AOVs. I'm going to save it to a multi-layer EXR. So in Fusion, let's import this EXR and let's preview it. So we just have one frame, but we have multiple layers here, and so Fusion is not the best compositing program to work with this multi-layer EXRs. But yeah, it can work. So to get the data that we need, and I'm going to just show you the motion blur in this case. So in the format, we have extra channels of our OpenEXR. So here we see our usual red, green, blue alpha channels, which is set to RGBA of the render. So this is the channels of the loader, and these are the channels that are in the EXR file. So the red channel from the EXR file is copied to the red channel of our loader, green of EXR to green of the loader, and so on. So to get our motion blur data, so by default it should go into the X and Y velocity channels. So if I go to these drop-down menus, you will see here the different passes that we rendered out in Maya. So we have our RGBA, we have our Z channel, we have crypto material, so the crypto matte, we have the motion vector, shadow, and these are the shadow matte passes. So they always have red, green, and blue channels. But the motion vector is, you don't have any data in the blue channel, it's just red and green. So the red will go into the X velocity, so motion vector R, and then in the Y velocity we have motion vector G. So if I now go to my preview window and click on this arrow, you'll see that we have other, besides our normal channels, we have also the vectors. So if I preview this, you'll see that this is exactly the same as what we have here, of course. So in Fusion, you also have to be a bit careful if you're setting your viewer on different channels. So here it's now on vectors. If I now want to preview another loader or another node, and it doesn't have a vector channel, it will give this error. So then you just need to set it back to color, and then it's fixed, of course. But so be aware on what kind of channel your viewer is, of course. So here we have our render, and to apply this motion blur, we need a tool in Fusion called Vector Motion Blur. So if we're in there, and by default, the X and Y channel is set to vector X and vector Y, which is correct and which corresponds to this X and Y channel. So if I zoom in a little bit here, so here we have our normal render, which is not completely rendered out, so you'll still see some aliasing here. And then if we go to the motion blur, you'll see that we have introduced motion blur into our render. This then can just replace our 3D render from before. So if I just put this into the brightness contrast tool, which will take care of the alpha so that we don't get those remaining values in other parts of the scene. And I just go to the end and preview my crop. So we're just changing out the layers, and in this case adding the motion blur, so we can change out our stand-in sphere object and use this this higher production value object. And so if I zoom in a little bit, so you can see the difference here. If I disable the motion blur, so this is without motion blur, and this is with, and it may seem like a little difference, but it really makes a difference in how well your object integrates into your composite. If you don't have motion blur, an object's movement will appear like stroboscopic, like a bit, yeah, it just looks a bit unrealistic. Now this vector motion blur also gives you the opportunity to play a little bit with the amount of motion blur. So you can, for example, double this, and then we will get, and so now you see we get more motion blur in our object without re-rendering our scene. Now let's also have a quick look at the Z pass. We don't really need it in this case, but I just want to show you quickly. So in our loader, we have also this Z channel, and I've already set it here to the R channel of the Z. It doesn't matter which channel you choose. And so then you can see that in this channel we have a depth, and so it's completely white. But if you look at the Z values, let's see if I can, so there is data in there, but it's just a very super white value. So all values are above 1, so everything just appears white. Now we can normally, if you check this normalize image, you would see actually what is there in terms of data. You would see the scene in a black and white version, but in this case it doesn't work, but we can show it in a different way. So here I just copied the loader and I set the Z channels to the red, green and blue channel of the loader. So you see RGB, and I then take a channel boolean and I put it to divide. The rest can be just as is. And in the foreground input, I set the background and I set the value of the RGB channel to the farthest value that I want to be in my image. So if I take the distance in my 3D scene, like what is the distance from the camera to the most furthest, the farthest point in the image. And so if I preview this, so if we divide this 2200 with the RGB channels, and so let's put this back to color. So now you see if I just set my background also to the same resolution as my render. So here you can see that data that is actually present in our Z channel. But we don't really need this to apply the depth of field, but it's just to show you how this layer or how this AOV works. And so what we have in Fusion is a depth blur. Now it's not the best kind of depth of field tool. There are also other plugins that can have better results, but I'm just going to show you this right now like that. So by default the blur channel is set to Z, so it means that it's going to need this Z channel in the loader. And so we can go from here into the depth blur. And then, so as you can see, there is some blur applied to our image, but let's say we want our focal point to be at this depth of our scene. So we can just take this focal point and just put it in here. So now once we have selected our focal point, you'll see that the rock is sharp, but then in the background and in the foreground we become more and more blurry. Here on the ground this part is also in focus. Now with the Z scale you can actually compress or expand your depth of field. So let's say that we set this a lot lower, like 50 for example. So you'll see that from our point where we selected, there will also be some depth of field or blurriness already appearing on the rock. Now this depth of field value is also to make a transition between the focal point and then before and after that. So if I put this a little bit higher, it will actually put 10 more values before and after this value to be sharp. So that way you can expand again the area that is in focus. The blur size is just how much blurriness is applied on the parts that are not in focus. So now this is a very exaggerated depth of field, but it's just to show you how this tool works. Now as you can see, if you exaggerate, you're just going to get very weird results. And this is most of the times the issue, is that you get these edges and also these blurry halos around the objects that are in focus. So this is one of the not so good parts of the depth blur, but if you just need to add a little bit of depth blur, you can definitely use this tool. But in this case, I'm just going to not use it. It's not really necessary, so I'll just delete it. Now that we have tested one frame with the motion blur and see that it works, we can then decide to render out the whole sequence out of Arnold. Another way to achieve motion blur on a moving object in a 3D render is instead of the motion vector path, we can just render out the motion blur directly in our 3D. There are definitely cases where using a motion vector path will achieve worse results than rendering out the motion blur directly in the render. But rendering out motion blur directly does give a lot more render time. It makes your render a lot harder for your computer, and you have less versatility afterwards. You cannot change the motion blur a little bit, like give it a little bit more or a little bit less motion blur. Then you'll have to do your render completely over. So then you have to be really sure that your motion blur is correct the way you want it from the moment you start to render. But just to demonstrate this, if you want to render out motion blur directly, you just make sure that in the motion blur tab, the instantaneous shutter is off. And if I then render out just a small part of my frame, so you see that now the motion blur is directly applied onto our image. And it's also, it has its consequences, of course, also in alpha. And you see that you get a little bit of chatter here also in your alpha. So in some cases, it would mean that you have to up your anti-aliasing, your camera samples. So these, because it's only the camera samples that can help with noise that is present because of motion blur, and also depth of field. So you can also render out depth of field straight in your 3D render, but then you'll have to activate it on your camera. So on the camera, you also have an Arnold tab, and there you can enable depth of field, and then you can set the focus distance, the aperture size. I have many controls of how your depth of field should look. But the same with this, then you are stuck with this depth of field, of course, in your final render. And it will take more calculations, or you will have to increase your camera samples to get a good quality result with no noise. One more important setting for when you're working with the Cryptomatte is to go here and select the AOV node. And then if you scroll a little bit to the _AOV_Cryptomatte, be sure to enable preview in EXR, else the Cryptomatte node doesn't work in Fusion. You can also access it in Hypershade. So under materials, you will find this AOV Cryptomatte material. And if you graph it, you get this node, and here you can do the same setting. Another thing to know is that if you are rendering with the render view and then saving out the merged, the multilayer EXR, the Cryptomatte layers also don't work. It only works if you render out to a sequence and then to separate image sequences. So I've now just rendered out a few frames of a sequence in a lower resolution, and so I will now just show you in the comp file. So I will just take a loader, and then in my render folder I have so for every AOV that I selected, I have a separate image sequence. So I have my beauty, which is the same as we see here, and then we have the crypto, the motion vector, the position, the shadow matte, and the z depth. So let's now take a crypto object. And so if you preview this, you get this kind of image where every object gets a different color. And to get an alpha or a matte from an object that is visible in your scene, you have to get the Cryptomatte tool, and you can get that via Reactor. So if you open Reactor and then just look for Cryptomatte, and here it is, and then you just install it and restart Fusion, of course. Then if you have your Cryptomatte layer, you can find the Cryptomatte tool there, and then just preview it. You get this kind of selector, and then you can just select an object. So let's say we want an alpha or matte for this object. So then you just put the locator there and then add it to the matte list. So then you'll see you get in your alpha actually the alpha for this object. If on the other hand you want it for the scene, the background, you can put it there, and then it will take that. And so for every object in your scene with this Cryptomatte layer, you will have access to all those mattes if you need them. And then we also have, of course, the crypto material. And so this is similar, but it's just so if there would be two objects with the same material, then you would select both objects with the crypto material layer. But in essence, it works the same way. But do remember, So in Maya 2019, on the AOV CryptoMat node, you have to enable this preview in EXR, and you have to render out to a sequence, so you have separate image sequences. As mentioned before, Fusion is also not the best software where you work with those multi-layer EXRs. So if you have the separate image sequences, you just load in every sequence separately, and from there on you just make your composite. So I just did the test render on one frame, and it's about 13 minutes to render. So that would mean for 100 frames, my computer would be rendering 21 hours for just 4 seconds. Now, sadly, we don't have a render farm at school yet, but there are, of course, some companies who do offer rendering capabilities through the internet. One of them is Zinkrender from Google. So this is the website, and if you register there, you get like $300 free rendering credits on their infrastructure, but you do have to have like a credit card to register. Also know that this is just a one-time thing, so if your $300 of render credit are over, then you will have to start paying for rendering, of course. Also know that if you try to sign up with different mail addresses and try to get multiple $300 credits going, they have ways to seek you out, and then they ban you from using their render farm. There are many other companies who also offer rendering capabilities, but Zinkrender is really very user-friendly. You just download like a client app. It installs a few plugins on the software that you want to use with Zinc, and then it's through a web console where you can just see what your jobs are doing and if they are rendering. So I rendered the version out of these 100 frames, and it cost me on their render farm about $7–8. But then you also have your 100 frames in like 30 minutes instead of waiting a whole day. Now it's definitely, I mean, it's just, I show you that these things exist. It's just up to you if you want to use them or not. So I made another preview of the result now, and so this is where we're at now. In the next video, I think we will start working a little bit more on the key and try to combine different keyers and have some techniques and tools for that. So see you in the next video.